Hi, this is David from Electric Teaching, and I'd like to try to show you how to factor quadratic trinomials with a leading coefficient that is not 1. That is a that is not equal to 1. For instance, see the ones down here, we got a 2x squared, 2x squared, 4x squared, 3x squared. Before I do that, I want to do a quick reminder of how we FOIL these, because in a sense we unfoil these. And if the more you understand the foiling, in other words working this direction forward, the better off you're going to be. If I was to get this answer, I would FOIL them. In other words, I would do the first 3x times x is 3x squared. I would do the outside, if you notice I'm just distributing the first term. That's all that FOIL is a distributing trick. What do we got? 45x's there. 15 times 3x, yep. Inside, negative 2x, and the last term is a negative 30. You always want to collect these, so it'll be 3x squared plus 45 minus 2, so 43x minus 30. And this is the collecting like terms, after we finish. So this is our quadratic trinomial, And I just want to show you an example of what it looks like to move forward. Now, if I wanted to factor this quadratic trinomial, it would look like those two binomials multiplied. And that's what we're going to do with these. When I help my students in class, I want to help create a way, not a formula, not a procedure, but a fast way to guess and check it. Some books have broken this down to multiplying a formula and then all of a sudden getting the answers. And I rather kids learn to play with the numbers and be comfortable with the numbers, especially the factors of the last numbers here. Let's start with this number 1, 2x squared plus 15x minus 27. Since the 2 is in front, that means one of the binomials is going to be 2x and the other one's going to be x. When this is the case, I want the students to kind of jump start it and write 2x parentheses and x parentheses to get us started. Now I want the students to do a little scratch work. So what I want them to do is I tell them to write a 2, draw a line under it, and list the factor pairs of 27. As you're listing the factor pairs, since this is a minus 27, that means we're only looking for negatives. So we're only looking for differences. That means if it's negative multiplier, you only have a difference when it comes to summing the factors or collecting like terms to 15. So let's look at 1 and 27. What I tell my students is to take the 2 and multiply it to each one and look at the difference. So 2 times 1 and then a difference with 27, that's not 15. 2 times 27 with a difference of 1, that's not 15. Next factors, 3 and 9. 2 times 3, 6, difference with 9, nope, not 15. 2 times 9 is 18. Difference with 3 is 15. We do have a match. I now know the 2 needs to be multiplied to the 9. Well, the only way the 2 is going to get multiplied to the 9 is if I put it over here. And that's why I wanted to make sure you understood the foiling. See the 3x times the last term over here, the last part of this binomial. So that's the outside. So I know the 9 goes there, the 3 goes here, and we just have to see which one's plus and which one's minus. Since it's a positive 15, it means I need the bigger 18 to be positive and then minus the 3x. Let's try that again. Again, negative 24 means we're going to have a difference. A difference is all we're looking for. So I want to set up the only possibility for the front terms, 3x and x. And I want to look at that idea that one of the factors is going to get multiplied. One of the factors is going to get multiplied by a 3. So again, we're looking for differences only. Textbooks would tell you to look for sums as well. Don't waste your time. Right now we only need differences. 1 and 24. Will I have a difference of 34? 3 3 times 1, difference with 24, no. And 3 times 24, difference with 1 is not 34 as well. Let's try the next ones, 2 and 12. 3 times 2 is a 6, and the difference with 12 is a 6. That's not 34. See the playing that we're doing? This is the most important part of this, I feel. 3 times 12 is 36 with a difference of 2. A difference in, with minus 2 would have a difference of 34. We found it. The 3 needs to get multiplied to the 12. So the 3 needs to get multiplied to the 12. Means 12 goes there, 2 goes here. What's the plus minus situation? Figure that out last. Since it's a negative sum when we collected like terms in the middle, that means it's a negative bigger value of negative 36, a negative 36, and then a positive 2x will give us that answer. And if you refoil it, it checks. Same idea here. Let's get it going. 2x and x, same idea. Now, this positive 12 means we're looking for sums. We're looking for sums this time. I'm going to put a 2 with a line over it and start listing factors. A neat little way to organize your scratch work when it comes to guessing and checking to find the factors. Now I'm not looking for differences as I multiply. 2 times 1, I'm looking for sums. So 2 times 1 plus 12. Is that 25? No, it is not. So 2 times 12 is 24 with 1. Uh-oh, we found it. There's the 25. The 2 needs to be multiplied to the 12. That's the key here. And the 1 must go right here. What are the actual signs then? What are the actual signs then? Let me clean that back up and put it in the green color here. So we want 12 and a 1. And have you figured out the signs yet? Well, if it's a positive, the only way we're going to get a positive value of multiplied of 12 is they're both negative or they're both positive. 2 negatives would multiply and make 12, or 2 positives will. Since the sum's positive, must be these are positive, and that's the only way to get the positive sum. This one's slightly trickier. We have a 4x squared in front. That means in theory it could be 4x times x, or 2x times 2x, So that's 4x and x. That would give me a 4x squared. Or it could be this one, 2x times 2x. That gives me a 4x squared. So I've got to consider that I might need to think of both 2's multiplied to factors down here, and that's how I would kind of guess and check my way to find the 43 middle term. I would list the factors of 30, 1 and 30, 2 and 15, and I would multiply 2 times and 2 times because 2 is going to get multiplied to each of these middle terms, linear terms that are going to be collected. So, but wait a minute here. If I double anything, it's even. And if I take 2 even numbers and add them, it's even. And since this one we are looking for sums again, we have a positive 30, so we're looking for sums. That means these are going to have all even answers. Well, 43 is not even. So I immediately know to change this and start looking for 4 times one of them and 1 times one of them. So again, I'm going to do the same trick that I did up here and on the rest of them, the other parts, my other scratch work. So I'm looking for a sum of 43. 4 times 1, 4 with 30. That's not 43. 4, I have to go this direction too, because you have to understand the 4 could be multiplied to here, or I could put the other numbers and switch them, and the 4 could be multiplied. The 4 will get multiplied to that value. But I could switch these values, so we have to figure out which one's right. So 4 times 30 needs to be checked. 4 times 30 with 1, added to 1, not 43. 4 times 2, 8 with 15, not 43. 4 times 15 is, what is that one? 4 times 15 is 40, and 60, and that one is 2 is not 43. I'm having trouble finding my factors here. Maybe there is no breakdown. Maybe there is no breakdown. So I want to just double check that I have everything written out correctly here. Oh, wait a minute. You know what I did wrong? I know what I did wrong. I forgot to list 3 and 10 when I was looking for factors of 30. Now let's double check. 4 times 10 is 40, and added to 3 will be 43. So through all this kind of messy scratch work, we have guessed and checked, logically guessed and checked our final answer. I'm going to need to have the 10 over here. The 10 will go over here, and the 3 must go over here to get us an add of 43. Now they're either both positive to make a positive 30, or they're both negative, and with a negative middle term, I think you can see they're both going to be negative. So there's my final answer. Let's see if I can box out those two binomials multiplied. So this is how you try to factor, and I feel this is the healthiest way to develop a good mathematical mind, to play with numbers and get comfortable with factors and understand this whole idea. And after you do this a few times, you're going to get quick and easy, and it's better than any procedure a textbook could give you. I'm David from Electric Teaching, and I hope this has helped. Thank you for listening.